So good afternoon to all and welcome to lecture number 9. And today we will start chapter number 3. This third chapter is basically a mathematical modeling of dynamic systems. So in this chapter, we will be studying the canonical form of the feedback control system, transfer function and its impulse response, differential equation and transfer function of physical systems such as mechanical, electrical, electrochemical, thermal, pneumatic, and liquid system. After that, we'll study the analogous system between electrical and a mechanical system. That analogy may be based on force voltage or force current or torque current or torque voltage analogies. So we'll study all those things. And then after that, once we study this analogy between the mechanical system and electrical system, after that we will study how to represent the system with block diagram, and then how to reduce the block diagram into a single block to find out the overall transfer function of that system. So this is one of the way of finding the transfer function of the system. And then second way is signal flow graph. This block diagram reduction technique is a bit tedious and it requires time. So to overcome that one, another technique which was proposed by Masons, as a Mason, he has proposed a Mason's gain formula. So we'll study that Mason's gain formula and which is applicable in signal flow graph. So with the help of that signal flow graph, we can find out the transfer function of that system and so on. So this is overall syllabus of third chapter. So it is big chapter as compared to the first chapter and second chapter. This will be basically this will be taking near about 10 hours time or something like that to finish this chapter, whereas chapter number 1 and chapter number 2 was just covered within 4 hours. So in total 8 hours we have covered chapter number 1 and 2. And yesterday I talked about that you have to submit the assignment. I hope that you know it based on the Laplace transform, right? Now question comes in our mind is that what is my model? So here we are talking about the mathematical modeling of dynamic system. So first thing is that what is model, and then what is mathematical modeling and why it is used, okay, and then how to obtain that mathematical modeling. So that we'll study in this lecture. So model, you know that model means, sometimes you might have prepared in your first year also that model of some job or some process or something like that in your workshop, or even in you have this another lab which was there. So in that lab you might have studied that how to create the model of any process or something like that. So model is basically a simplified representation or abstraction of reality. Okay, so it is a representation of reality, okay, or abstraction of reality. So reality is generally too complex to model exactly. Okay, so here what is by mathematical modeling or something like that? So mathematical modeling is nothing but representing that system with the help of mathematical equations. Okay. Now, simple example is that, okay, if you apply a voltage across resistance, because you people are electronics engineer, okay, engineering students, and you know the Ohm's law. So Ohm's law is V is equal to I, voltage across the resistance. Okay. That relation is given by Ohm's law, which is equal to V is equal to I into R. R is the resistance and I is the current flowing through that one, and voltage is V is the voltage across that resistance. So this model is obtained basically. So this is V is equal to I into R. This relation, mathematical relation, is nothing but the mathematical model of that resistance. Simple resistance means, if we know the voltage and if you change the value of resistance, you can easily calculate the current. Or if you know the current and if you know the voltage, you can easily calculate the resistance. Or if you know the value of current and resistance, you can easily calculate the value of voltage. This is because, okay, you have used the existing laws which are available, rules and regulations, and so on. So by using that one, for that resistance, you have developed that model, and that model is given by V is equal to I into R by using Ohm's law. So mathematical modeling is a set of mathematical equation, for example, differential equation, that describes the input and output behavior of the system. So I give the example that this resistance is there, right? So across this resistance, we have applied voltage V. So how much current will be flowing through that one? So that will be equal to I. According to Ohm's law, V is equal to I into R. So you can calculate any type of, at any time you can calculate the current or resistance if you know other two parameters, right? So you are using the existing laws which are available in that field. So for example, in electronics or electrical field, which are the well-known laws. So you know that Ohm's law is one of the law. Then Kirchhoff's law. In Kirchhoff's law, there are two laws are there. One is Kirchhoff's voltage law, KVL, which is applied across the loop. And another one is Kirchhoff's current law, okay, KCL. So these are the well-known laws which are used widely in this one electrical or electronic system. Similarly, in a case of mechanical system, you know that Newton's laws are there. So there are three Newton's laws, so which can be used for modeling the mechanical systems, whereas Ohm's law or Kirchhoff's laws are used for modeling the electrical or electronic systems. So as you get, see that means apply, see suppose for example simple RLC series circuit is there, and if you apply the voltage across that one, you have studied that one in your second year network analysis subject. So R, L and C which are connected in series, and across that one we have collected a voltage source V. So you know the relation that V is equal to I into R plus L di by dt plus 1 upon C integration of I dt. So that is the whole equation of that RLC series circuit, and that is nothing but the mathematical model of that RLC series circuit. So what we have done here, we have applied the existing law of simple Ohm's law we have applied there, or Kirchhoff's current law we have applied there, or Kirchhoff's voltage law we have applied there. So by applying the existing laws, we can model that physical system in terms of mathematical equation, and that mathematical equation describes the input and output behavior of that system, and that mathematical equation is called as the mathematical model of that system. So I just gave the example of simple resistance. So what is the mathematical model of that simple resistance? V is equal to I into R, or RLC series circuit which is connected across this one voltage source V. So that mathematical model of that one by applying Kirchhoff's voltage law KVL. So V is equal to R into I plus L di by dt plus 1 upon C integration of I dt. So that will be the mathematical model of that RLC series circuit, which can be explained by using Kirchhoff's voltage law, so existing law. So which will give the relation between input and output. So which will describe the input and output behavior of the system. Now, for what purpose this mathematical model is used? So mathematical model is used for simulation purpose or for predicting or forecasting. As I said that, like for example, you have connected the voltage across resistance. Okay, so resistance is known, right? So this is fixed value of resistance. Now, if you change the value of voltage, can you calculate the value of current? Yes, because you know the mathematical model of that one. So which is nothing but V is equal to I into R. So if V is changing, R is fixed here. Okay, definitely I will also change. So what is the value of, okay, what kind of current will be flowing through that resistance for that particular voltage, you can predict easily and so on. So for prediction or forecasting something, or for diagnostic and designing and performance evaluation, in control system design also you need a mathematical model of that physical system. So from that mathematical model, we can investigate the stability of a control system, like whether that system is stable or unstable and so on. So I hope that you have understood what is by mathematical model. Means mathematical model which is described with the help of mathematical equation. Now this mathematical equation, where from this mathematical equation will come? These equations will come from existing laws available. So you have to use the standard laws in that field, apply that standard law, and then model that one. So you obtain the mathematical equation. So that mathematical equation will give the relationship between input and output, and that mathematical equation is nothing but the mathematical model of that system, and which is used for simulation purpose or prediction or forecasting purpose or prognostic and diagnostic purpose or design or performance evaluation and in control system design and so on. So I hope that you have understood what is by mathematical model of the physical system, right? Now, there are three types of models. One is black box model, another one is gray model, gray box model, and the third one is white box model. So what is the difference between this black box model, gray model, and this one, white model? Actually, we are going to use the white model, but just for understanding purpose, okay, I'm describing here or discussing here about the black box model. So suppose, for example, if you don't know anything about what is there, what kind of system is there, but you know the input and you know the output. So from input and output, okay, you can model that system. Okay, and so when only input and output are known and internal dynamics are either too complex or unknown, so that model, whatever you get from input and output relationship, that model is called as the black box model. And then this is easy to model because, okay, you are just modeling from input and output relationship. So you don't know anything about what is the dynamics inside this plant or system and so on. So you don't know that. That's why it is called as the black box, right? Because you don't know anything about that one, right? And you are modeling from input and output relationship. Okay. Whereas gray model means what? You know some parameters, not full. Okay. So when input and output, so you know input, you know output, as well as some information of that internal dynamics of that system is known, not full information. So that's why it is called, it's not fully understood, it's partially understood. So this model is called as a gray model. And this model, designing this model with the help of the partially available and also input and output relationship, it is easier than white box modeling system and so on. Okay. So this is about gray model. So in case of black box model, nothing was known in the dynamics of the system, whereas in gray model, only partial information was known and input output was also known. Whereas in white box model, you know every parameter or internal dynamics are known, input is known and output is known. So this is totally transparent system, and that's why it is called as the white box model. So when input and output and internal dynamics of the systems are known, then that model is called as the white box model, and one should know complete knowledge of the system to derive the white box model in that case, right? So if you know everything about the dynamics of that system, then you will be able to model that one. So that will be a white box model. So to be complete transparent system, you know everything about that dynamics of that system. So now we'll see how to obtain the models of a simple electrical system. So you know that in electrical system or electronic system, you have basic elements like as a resistance is there, or you have this capacitor is there, or inductor is there, diode is there, transistor is there, and so on. So diode and transistors are basically logarithmic devices, whereas this resistance, capacitor, and inductor are not logarithmic devices. So you know, okay, first we'll try to understand what is the individual model of resistance, what is the individual model of inductor, what is the individual mathematical model of capacitor, and so on. So this is the resistance, and the symbol of this resistance is this one. Okay, I hope that everybody knows. And when you apply the voltage across this resistance, okay, by using Ohm's law, you can find the relation between voltage, current, and resistance. So the time domain expression relating to voltage and current for the resistor is given by Ohm's law. So which is VR is equal to IR into T. So IR is nothing but the, see, VR is nothing but the voltage applied, okay, applied across the resistance R, and IR is nothing but the current flowing through that resistance R. This resistance is R. So if you know the voltage and if you know the resistance, you can easily determine the value of current flowing through that resistance, or if you know this one current and resistance, you can easily calculate the voltage. So any two parameters, if you know, you can easily estimate the other third parameter with the help of this existing law. So this is nothing but the mathematical model, because this resistance is represented mathematically by this equation, and for obtaining this one we have used the existing law, that is nothing but the Ohm's law. So this is basically Ohm's law. By using Ohm's law, you got the mathematical model.
Hello, sir. You are not audible, sir.